Okay, so let's, oops, drop my phone. Give me a second. So let's get started. I think it's time to start our second recitation of CS 2100. So today we'll do some announcements first. The course is, like I said, previously pretty fast, so there is quite a few announcements to go over. And then we'll do a bunch of problems related to predicates implications and then the basics behind doing proofs. So I think, so that's our plan for today. So let me first go through announcements and then we'll see if there are any questions. And I'm kind of guessing there will be some, or maybe even a lot. Okay, so like I said, there is a bunch of them. So homework 1 is due this Friday, September 4th at 11:59 p.m. So basically at midnight this Friday. Then our first quiz will be next week on Tuesday. So that's September 8th. On Canvas, you can find the guidelines and the rules for this quiz. In short, it's going to be online. The window is, I think, from 7:30 a.m. to 4 p.m. when you can start it. And then you have, well, no, I should say you have to finish it by 4 p.m. And we have 1 hour to submit it. I already created the quiz. I think right now there is, I think, 8 questions. I would say half of them you should be able to go through pretty fast, and then maybe the other half takes a little bit of time, but I don't think it's a hard quiz. And so to prepare for the quiz, we already posted the practice quiz on Canvas. I strongly suggest that you go over this quiz and try to solve it. And then there is, of course, a number of office hours between now and the quiz. You can use any of these office hours to come and ask questions and get help with the problems. And then on top of that, we have this, let's say, special office hours that we'll use as review sessions for the quiz. And I'm listing it here on the slide. So there is 3 blocks on Friday, September 4th, so this Friday. And even though September 7th, which is Monday, is the holiday, because the quiz is just the day after that, there will be a review session on Monday as well, if you want to tune in for that one. And so these sessions will be geared towards answering questions and going over the problems related to quiz 1. But just to mention this again, of course, you can go to any other office hours as well to get one-on-one help. Okay, then on top of this, we also, as we promised, created quiz 0. And the only purpose of this quiz is to test grade scope on the student side and the submission process and so on. And so quiz 0 is going to be open tomorrow on Wednesday. And you can read the Canvas announcement about this to learn about the details. Know that it's not graded, but please make sure to do it to test your home setup for submitting exams. So you have to submit our exams online. You have to, either scan it or do it with the phone. And tomorrow is the time to test your setup at home to make sure that you know how to do it and to make sure that you can actually do it. During the actual quiz, there won't be that much time to, then go through all the setup steps and so on, because you have only 1 hour to solve it and submit it. So make sure to test it tomorrow. And then tomorrow is also then a good time to read the pledge and the rules for the quiz. So the pledge and the rules that we included in quiz 0 are the same ones that we will use for quiz 1 as well. And so there's kind of 2 pages of text. It's an online quiz. There is quite a few rules. So tomorrow is a good time to go over this as well, so that you are prepared for next Tuesday for the quiz. And do all of this so that during the actual quiz, you don't run into problems. If you get stuck during the actual quiz, you cannot submit it because you didn't do quiz 0. We won't accept that as an excuse. So of course, on the day of the quiz, so next Tuesday, there will be no recitations. So that means that, you can take your recitation slot to use it to solve the quiz. But you can actually do it at any point in time you want between 7:30 and 3 p.m. And then there was a question about this last time. During every exam, you are allowed to have an index card where you can write down kind of reminders about definitions that you need and so on. And on Canvas, it's described how this index card has to look like and so on. And you have to submit it with the quiz as well. Okay, I see that there are already a couple of questions, so let's maybe now go through those and cover them before I move to the next slide with announcements. Okay, I guess I can read them on my own this time. What is the time slot on Tuesday for the quiz? Double check it on Canvas, it's already announced. It's in the syllabus and so on. How big will the index card be? Again, that's all on the Canvas. It's basically a double-sided, letter-sized piece of paper. It's important to not forget to scan your index card and submit it with your quiz as well as the pledge. So all of these rules are on Canvas. Okay, let me do the next page of announcements. So about the regrading policy, this is all in the syllabus, but basically the main thing to remember is that you have 1 week from the day you received your score through Gradescope or Canvas to request regrading. So, you cannot request regrading beyond that. So, if you think that something was graded wrong and so on, submit your regrading request as soon as possible and at most 1 week after you got your grade. After that, we will not accept regrading requests. And then related to problem sets, they're pretty easy. So the regrading requests happen rarely, but to request it, use Piazza. And again, we made an announcement about that recently. All other regrading requests, so for homework assignments, quizzes, and final, you do through Gradescope. So Gradescope has an option, functionality, where you can request regrading. Okay, so that's announcement to regrading. In preparation for quiz 1 and the homework that is due on Friday, please leverage TA office hours. We do have a lot of them. They're set up for you. And so do that. And, exercise, make sure to solve a lot of problems. That's the best way to prepare. And of course, there is always Piazza. So if you have any questions, post them there, and TAs are keeping an eye on it all the time, and they'll respond. So everything what I'm saying is already described in the rules for submitting exams. But, I'm just trying to stress out what I think are the most important things. Of course, you should go ahead and read those rules on your own as well. So one important thing is when you're submitting anything through Gradescope, you must match questions to pages. So Gradescope will guide you through that. And so to be eligible for points, you must do the matching on your own, and you also have to show your work. Also, of course, be careful that, when you're scanning your quiz, that your writing is actually readable. And you can try that during quiz 0 as well. Usually it's better to use a pen than a pencil, for example. And then again, there is this index card that you can use. It can be one sheet of letter size paper, and you have to submit them in your solution. Okay, let me go back to questions. So for quizzes and exams, are we allowed to write directly onto the PDF on our iPad and submit it that way? So Aaron asked that. So yes. So if you have a way to write directly to your PDF and you're comfortable with that, you are more than welcome to do that. Another way is to use pen and pencil and then scan it in either with your phone or a scanner. And then we also provide Word and LaTeX templates. So if you are adventurous and you want to use Word or LaTeX and you are comfortable that you can type in math by doing that, then you can do that as well. You can also write directly onto PDF if you have something like Acrobat. So those are all different ways that you can submit. So as long as it's a PDF document and it's readable and we can grade it, you should be fine. Will quiz 1 include material from lecture 5 or only material covered during lectures 1 and 4? So it will include everything up to proofs. So proofs will not be in quiz 1. The next question, will we be supervised during the quizzes and final exam? I'm not sure what you mean by supervised. We will not use any of these like Proctor U things and so on to monitor you at home. But of course, we will be monitoring Piazza, where you will be able to ask any kind of clarifying questions about the quiz and so on as you are working on it. So there will be that. And of course, you will have to sign a pledge that you will not communicate with other students, that you will not take any kind of solutions from other students, and so on. So you should read the pledge because you will have to sign it and submit it with your quiz. If you don't sign the pledge, we're not going to grade your quiz. The next question, do we need to print the quiz to write on it, or can we use blank paper and write the question number at the top? You can totally use a blank paper. So you don't need a printer to be able to solve the quiz. The main thing here, and I already mentioned this, is that you have to match your questions on these pieces of paper that you're going to use once you scan it in Gradescope, right? So in Gradescope, you are going to say, okay, my answer to question 1 is on this page. My answer to question 2 is on this page. So make sure to write to solve only one question per page. The practice quiz is tomorrow. And the pledge is in the practice quiz. So this is a good question. Do we need to print out the pledge and attach with our quiz after signing? So yes, you have to sign the pledge. And let me look into what if you don't have a printer. If you don't have a printer, just write on an empty page. I confirm that I read the pledge and I'm signing it here, and then you sign it. So you can do that again using just pen and paper. You don't have to print the pledge. And we will accept that as if you signed it and printed it. Okay. Any other questions about any of these announcements? I already stressed this out last time. Make sure to read the syllabus and all the pages attached to it. You know, what I announced here is what I think is the most important in terms of rules and guidelines for the quiz. There is a bunch of other things that are related to it as well, and you should read all of those on your own and then ask questions if there are any concerns about it. So you should read rules for cheating, how to submit your quiz, do quiz 0 tomorrow, read the pledge, read the rules for the quiz, and so on. Okay, I think that's it. If there are no more questions, we'll move on to solving some problems. Okay, let me close the chat for now. Okay, so let's try to solve a couple of problems related to recent lectures. We'll start with a couple of simpler ones, at least I think they are. And then towards the end, we'll see how much time there is. We'll do a couple of proofs as well. Okay. Okay. Let me just see the chat. Maybe there's one last question. Okay, these are just comments. So first, we'll do two problems related to quantifiers. By the way, unlike last time, you know, with every recitation, I'm feeling a bit more and more adventurous. So I'll give you a minute or two to try to solve a problem first before I solve it for you guys. And also, once we start doing proofs and so on, we'll use breakout rooms as well. So I'll split you, the whole, everybody who's participating, into a number of breakout rooms with a couple students in each room. And then you'll be able to discuss your solution with your peers and get to know each other a little bit and so on. So that's the plan for today. Okay, so let's do the first problem. So what does it say? Write each of the following statements using quantifiers and standard mathematical notations. So for statement 1, for every integer x, x squared plus 1 is positive. Statement 2, there is an integer n such that 2 to the power of n is equal to 32. So I'll give you a minute or two to try to solve this on your own. And then I'll write down solutions as well. And I really encourage you that, you know, you actually do get a piece of paper and a pen and try to do this as we go along, because that's a good way to learn. Okay, so I hope you gave this a try. So let me now do it. So this is all about introducing quantifiers. So as soon as you see something like for all or for every, this is the symbol for all. So for every x, that is an integer. So it's an element of z. X squared plus 1 is positive, meaning greater than 0. So that's number 1. And number 2 So it says there is an integer or there exists an integer. So here we have to use our other quantifier, there exists, which is this kind of turnaround E. So there exists an integer n. So n is an integer. By the way, don't forget this part. So that specifies that n is an integer. Such that, okay, 2 to the power of n is equal to 32. Okay, so this solves this problem. Any questions about the solution? Okay, so let's then move to the second one. Know that quantifiers will definitely be on the quiz, so make sure to study them. Okay, so in this problem, we are going to negate quantifiers. So we want to negate the following statements. We want to determine whether the original statement or its negation is true. And we should use standard mathematical notation for quantifiers and propositional logic to do this. Okay, so why don't you first try to do it on your own? I'll give you 2-3 minutes, and then I'll do it as well. By the way, a small hint, to be able to express these ones, you will need to use implication in addition to quantifiers. So let me help you a little bit more. So to do this, so first you should write these statements as they are directly using logic and quantifiers. Then once you do that, then you should negate them. And of course, you should know how to do the negation of all the logical operators as well as quantifiers. And once you do that, then you determine whether they're true or not. So there is a little bit more work here. Okay, so let me try to do this and solve it for you. So let's write down the first one. Oh, sorry, the first one first. So let's first write it down. So we have for all number x, Note that we are not saying here whether it's integer or real, and so in that case you don't have to specify it. So x is between -2 and 2. So we have -2 less than x, and x less than 2. So this is specifying that it's between -2 and 2, implies that its square is between 0 and 8, implies 0 less than x squared, and x squared less than 8. Okay. So I see there are some questions. Let me take a quick look. Yeah, so do we have to include that it's reals? Let's actually do that. So in the quiz, we are going to specify which set it belongs to. So I have to say this number 1 is a little bit underspecified. But so to make it clear, let's say that x belongs to reals. And then there's a question, why do we say implies and not such that? So, well, you should definitely not be writing English words when you're expressing this. So, so you should only be using mathematical notation. And then, and so this is this implies is a mathematical notation for implies. And then it's not really such that. It's you know, the if then. So if x is greater than -2 and less than 2, then x squared is greater than 0 and less than 8. So, okay, let me see other questions. Why are yes? So there is a comment that we use comma for such that, and implication is for if then. So okay, then there is a question: can we say instead of using and here, instead of using and here, can we just write 0 less than x squared less than 8? Sorry, is the other one. So so don't do this. You should use and instead. So use this and instead. So spell it out. Let me erase this. I mean, there is more questions about this. It's a kind of a shorthand notation, what I just wrote, for using and. And we are not going to use this shorthand notation. Among other things, because it's harder to negate it, but also we want you want you guys to use and or and so on. We don't want you to use shorthand notation. And yes, this is a such that statement. So if you want to read this out, it says for all x in real numbers such that -2 less than x and x less than 2 implies 0 less than x squared and x squared less than 8. So that's how you read this statement in English. Okay, we have to move on. If there are things that are still unclear, there'll be office hours after recitations later today, and you can clarify them then. But these kinds of problems will be in the quiz as well. So if you're confused about it, make sure to really come to office hours and clarify any issues you have. So let's at least negate this one, and then we'll move on to the other problem. So let's negate it. So we want to negate this whole thing for all x element of R, such that -2 less than x and x less than 2 implies 0 less than x squared. I have to close the chat. And x squared less than 8. Okay, so we negated now this formula. However, okay, we're not stating this in this problem, but typically we will ask for you to push this negation as far right as you can into the formula. Meaning you should never have negation in front of a parenthesis. We want to get rid of that. And to be able to do that, you have to learn how to negate various parts of this formula. So let's do it step by step. So when we push it in, so negation of, let me just remind you of the rule. For all x, let's say some formula f. So if we negate this, that's equivalent to the resist x such that not f. So that's the rule that we are now going to apply to this big formula. So we get this is equivalent to the resist x element of R such that you have to negate this whole big thing. I'm not going to write it again. So we are negating this whole thing. Okay. Now what we have is an implication. So we have P implies Q, and we are negating this. And that is equivalent to, and again, you should know this, and I always have to think about it a little bit. P and not Q. Let me just double check. Not P or Q, P and not Q. Yeah. So that's another rule that you have to know. You have it in your books, and so you should know it. So if we're going to apply that on this big implication, we are going to get there exists x element of R such that P is this whole thing here, the whole left side, such that -2 less than x and x less than 2. And then we have not q, where q is the whole right side. And let me continue here in the next line. And then we have not 0 less than x squared and x squared less than 8. Okay, so we are almost there. We still have to push this not here, this negation here, into the parentheses. And so let's do the final step. So that's equivalent to the resist x element of R such that -2 less than x and x less than 2, and we have opened the parentheses. When we push this negation in, we get again, it's another rule to remember. So negation of p and q is equivalent to not p or not q. So when we get 0 less than x squared, we get 0 greater than equal to x squared, or x squared greater than equal to 8. So that's the negation. I'll stop here with this problem because we have a bunch of other ones that I want to go through. So let me actually move ahead with other problems. Okay, there is a quick question.
Do they have to write all the steps, or can they do it in one line as they move left to right?
Write out the steps. In this type of question, we are not going to look for, let's say, every minuscule step, like which is what we are looking for when you have the type of question where you have to use those rules to prove equivalence or something. But we still want to see some steps. I mean, here this would be like a big leap from the first negation all the way to the last formula. So maybe 2 or 3 steps would be reasonable. So yes, I will post the full solution for this. So after I finish the recitations today, I will go back and I will clearly write the full solution, and I will post this. So I will post this under scribbles for today's recitation. Okay, so let's move ahead. Okay. Okay, so let's do this one quickly. So this time I'll just go ahead and do it. Again, all of these questions up to proofs that will start soon. These types of questions you can expect on quiz 1. So what do we have to do here? Use these rules below, we've seen it before. Substitution rule and properties of implication to verify the following logical equivalence. Okay, here I have a little bit more space. Anyways, let me just at least start it here. So first, these rules below, they do not include any rules for the implication. But we should know these rules. You know, we have them in the book, and we should know different rules that apply to implication. So we want to prove equivalence, meaning that the left-hand side is equal to the right-hand side. So we want to, let's say, transform or massage the left-hand side into the right-hand side. So if we look at them a little bit, we can see that they're quite similar, except that kind of the order, the left and right-hand side of the implications are flipped. And so how do we flip the size of the implication? Well, there is this rule that we already talked about. It's called contrapositive. So we know that P implies Q is equivalent to not Q implies not P. So if we apply this rule on the left-hand side, we are going to get closer to the form of the right-hand side. So let's try to do that. So we have the left-hand side, P and Q implies not R or not S. We apply this rule and we get not R or not S implies not P and Q. Great. So as you can see, now we are a little bit closer to what we have here on the right-hand side about it. So let's now use some of the rules that we have below. So with this one, we want to push this negation into the parentheses. So we are going to use De Morgan's law, in particular this rule here. So remember, we always have to say which rule we are applying. So in this case, it's De Morgan. And then we get, what do we get? We get not R and not S implies not P and Q. In this type of question, it's important to apply rules one by one. Great. Now the obvious one that we have is double negative. So let's apply double negative. On not R. And so we get this is equivalent to R and not S implies not P and Q, which is equivalent to, we do double negative again. It's equivalent to R and S implies not P and Q. Okay, so we are almost there. One more step, equivalent to. We are going to do another De Morgan, but in this case, we're going to use this rule on the left. And so we do another De Morgan. And we get it's equivalent to, R and S implies not P or not Q. Okay, so we managed to get left-hand side to be the same as the right-hand side, and therefore we prove this equivalence. Okay, let me now go and see. Okay. Any questions about this? Okay. Practice logical equivalences for quiz 1.
Yeah, how did you get the initial switch on the left side?
The first step?
Yes.
So I used the contrapositive rule. So I use this rule that I'm going to now circle. So that's what I was saying. So this problem is requiring that you know properties of implication. In particular, you should know the contrapositive rule. So that's the rule that I wrote down here. So I applied this rule to switch left and right sides of this implication. So that's what is happening there.
Will they be given theorem 2 for questions like this on the quiz, or should they write them down?
Great question. So yes, you will be given these rules, theorem 2 rules on the quiz. But you will not be given rules such as contrapositive. So, these rules below here, they will be given to you on the quiz, all of these. Okay. Okay. Let's do a simple proof. Okay. So we only have 4 minutes left. How do we do this? Yeah, so let's try to do this proof on your own right now. It's a really easy one. I'll give you a minute or two. So how do we do it? We want to state some facts about what we have on the left of this proposition. In particular, I want to state that n is even. And then we want to use these facts to prove that n plus 8 is even as well. And let me put you guys in breakout rooms for 2 minutes, and you can discuss your proof with your peers. And then we'll gather again in the main room, and I'll quickly go through the proof. So let me see. If we do 15, let's do 10, 12. All right, 13 rooms. Well, have fun, guys. We are kind of trying this a little bit, and let's see how it goes. So once I do this, you will end up in a room with a couple of your peers, and please discuss the problem and the solution, and then we'll come back and then I'll solve it for you. And make sure to introduce yourselves and so on. You'll have to click join the room to actually join the breakout room. Okay, welcome back, everyone. I hope this was fun. We'll do more of this in the future. And I'm sorry I'm going over time. I'll just quickly solve this for you. So we have if n is even. We've done this many times before. That means that n is equal to 2 times some integer m. So m is an integer. Okay, now we want to prove that n plus 8 is even as well. So we should use this fact to somehow prove that n plus 8 is even. So let's add 8 to both sides. Okay, so now, great. On the left-hand side, we have n plus 8. We want to show that that is even by showing that the right-hand side is even. So what can we do with the right-hand side? We can say it's equal to 2 times m plus 4. Wonderful. Then that is equal to 2 times some k, where this k is an integer. And we can do this because of closure of plus. Great. So we have that n plus 8 is equal to 2 times k, which means that n plus 8 is even. And that concludes our proof. Okay. Let me use maybe 1 minute to try to go through the questions.
Do they need to put QED at the end?
No, QED is not mandatory. I think it's a good practice to kind of finish your proof, but I'm just kind of used to it because I do proofs in my research and I always do it, but it's not a requirement for this course. Could we have proved the contrapositive? Maybe. That's a good question. So you would have to prove if n plus 8 is odd, then n is odd. I think it will be a little bit harder to do than the direct proof, but in this case, probably contrapositive would work as well. That's not always the case. Often, flipping it makes the proof much, much harder. But I don't think this is the case for this proposition. Any other questions? Okay, so we'll stop here.
I
Yes,
actually have one short question.
go
If
ahead.
we want to do it in contrapositive, we have to do like if n plus 8 is odd, then n is odd, right? Because
Yes,
it
exactly.
flips, right? Thank you.
Yes. Usually we will give you a hint, right? So if we don't say, hint proved by contrapositive, then you should probably not do contrapositive because it will probably be harder. But those are good questions. Okay, so it seems that there is a group that actually proved it using contrapositive. So I think what you did, yeah. So what you did is looks reasonable to me. So Alici, and sorry if I'm not pronouncing it right. You have a small typo. N plus 8 is equal to 2x plus 1, but that seems reasonable. And we really have to stop now because I have another recitation starting in like 7 minutes. So thank you all. I'll post scribbled notes to Canvas later today, and so you'll be able to get all of the solutions. Thank you.